Hello guys, today is the 3rd of February and this is the POTD of the 3rd of February of Leetcode. Question number 3105, longest strictly increasing or strictly decreasing Subarray. In this question we have given an array of integer nums. We have to return the longest Subarray, which is either strictly increasing or it can be a strictly decreasing. Okay, and the definition of strictly decreasing and increasing is here. An array is said to be strictly increasing if each element is strictly greater than its previous one if exists. It is saying if we have given, suppose, array 1 2 3 4 5, it is strictly increasing because in this every subsequent element is greater than its previous element. If 1 1 2 3 4 5 we take, then it is not strictly greater than. Okay, so 2 3 5 is a strictly greater, na? Yeah. Okay, and strictly decreasing like 5 4 3 2 1. An array is said to be strictly decreasing if each element is strictly smaller than the previous one if it exists. Okay, let's suppose that we have test cases 1 4 3 3 2, and we have to just find that it is maximum longest Subarray which is either strictly increasing or strictly decreasing. So we, in this we can say that 1 4 1 4, so it is strictly increasing. So we have find the Subarray of length 2 which is strictly increasing. Now we are trying to find the array, let's suppose 4 3 3. Here it is not strictly increasing and decreasing, but 4 3 is strictly decreasing. Okay, 3 2 is strictly decreasing. So we have just find the already 2 length maximum Subarray. So you can just read it. Strictly increasing Subarrays are nums 1 2 3 4 and 1 4, and decreasing are 1 2 3 3 4 3 2 4 3. And so we return the maximum length 2. In this case, here is not any strictly increasing and decreasing because they are also same numbers. If we are not using here strictly word, then we can say that it is the 4 times, but here we are using strictly increasing or strictly decreasing, means even it is not equal, so we have to return just 1. Okay, so this case you can see that. And now this is the 3 2 1. This is, this is strictly decreasing, 3 then 2 then 1, so this is strictly decreasing, and the maximum length of the Subarray is 3, so we are just returning 3. And here the constants here given very basic constants, so we can just apply brute force also. But if you want to apply then brute force also, so what is the brute force approach which we can think? We can take just a loop. Okay, then iterate in this. We are trying to make all possible Subarrays, then just check if it is decreasing or if it is increasing. Then if it is increasing, then take the length, maximize the length of the maximum Subarray. And if it is decreasing, also decreasing. If it is decreasing strictly, then also take the length and maximize the length, and finally return the maximum length. Okay, so you can do this brute force, you can apply and you can do by self with the brute force. I am coming to the optimized approach, and however I think for this optimized approach, actually initially I can't solve it with brute force, but I solve it directly with a optimized approach. I don't know, but after the solving it with optimized approach, I just also solve the brute force, because in interviews we have to just solve with the mostly even the first time we have to solve with the brute force approach, because interviewer thinks then it is already known the problems, and there's a negative effect on the interviewer for this. So this is a solution which we can discuss for this. Let's suppose this is the solution, and you can, if you want just the code, then just comment and I actually DM you. Okay, here if we are given the array nums, I take the variable and store the length of nums array, and I take the max length 1, because it is not possible that a length possible less than 1, so I'll take initial length 1 and length 1, because to check inside a array. Okay, maximum length to maximize. Okay, here I check traversing on the array if it is strictly increasing. If it is strictly increasing, I increasing a length, and if it is not, I just restart the calculating length 1, and I here maximizing the length. Okay, if it is strictly decreasing, I just again, if it is strictly decreasing, nums of I is greater than nums of I plus 1, I increasing a length and maximize the length. And if it is somewhere find that it is not strictly increasing, strictly decreasing, then I just again made length is equals to 1. So this loops runs up to the n minus 1th index, up to the n minus 2th index, because I take I less than n minus 1, because we are accessing I plus 1. Okay, at last we are returning max length. Okay, because we actually maximize the length from here and also maximize the length from here. You can just see that. Okay, and now we just run the code. You can see that. Yeah, let's submit the code. I already done it. If you want, then you can, I'm doing for you right now. And it's fast. Okay, and it beats also 100% user, because it has O of n approach, because we are traversing on the array one time, and actually we are traversing on it one time again. O of n, which is equals to O of n. Yeah, we can also do it inside the loop. Why why by making two variables, like increasing length or decreasing length. Okay, so if it is increasing length, we have maximized here, we use that variable here, and if it decreasing length, if we are use it here. Okay, so we also do can it in the same loop, but it makes complex to you understand how are actually loop working. So I make it in the two difference. Okay, and actually the first approach which I have think for the solution, basically it is a easy problem, but it is a good problem. Okay, if it is the not the just I am saying that if the constants are not simple, it can be say to the medium level problem up to. Yeah, I know it is a easy level, but it can go to up to the medium. Okay, it is easy to medium between. Okay, so this is the solution. If you want this code and like the way of my approach to solving the question, and this is an optimized approach, then you can just like the video and comment something which motivates me. Thank you.